Well, hello, 3C, ladies and gentlemen, boys and girls, cats and dogs, and anybody else that might be interested in applying sine law and cosine law. We're going to get down to it today because this one might actually go a little long. I've got 3 examples to do, plus just talking cases about what do we use, sine law or cosine law, when it comes up in an application. So, our goal today, I can set up word problems involving non-right triangles and solve using sine law or cosine law. You know what I'm going to do right now. I'm going to take my highlighter and I'm going to highlight non-right triangles. Now you can actually use sine law and cosine law in a right triangle as well. It's just more straightforward to use the primary trig ratio, so keep that in mind. So here we go, applying sine law and cosine law. How can we tell when to use sine law and when to use cosine law? Well, we talked about that before, what the cases were, what we had to have happen when we use sine law, or what we had to have happen when we use cosine law. I'm going to give you the 4 cases here again. Think about these cases. So I have an angle and the side across from it with known values plus one other piece of information. Now this is case 1. This is written in words. I'm now going to show it to you in a diagram. So I have an angle and the side across from it with known values. So that would be the case where we know that this is an 80-degree angle in here and the side across from it is 20 centimeters. And then it says plus one other piece of information. So if I have one other piece of information, let's say I know that this is 12 centimeters. Then if I know that's 12 centimeters, I can find this angle over here using sine law. Or let's say I knew what this value of the angle was down here, then I could find this side using sine law. So we just have one other piece of information, either one angle or one side with a known value on it. So this is one situation. Second case here, case 2. I have a triangle. Oh, and I should say this is sine law because we didn't actually say that that's we didn't write that down. Okay, so case 2. I have a triangle with the side lengths of all 3 known sides. So that's how we state it in words. Now I'm going to put it on the diagram. So let's say this is 12, this is 15, and this is 23. So we've got all 3 side lengths. Now do you remember which this one was? Yep, I think I hear somebody said it. This is cosine law. And this is more specifically the cosine law that finds angles, because I got all the sides, so I don't need an angle. And I'm just going to write that down here just really quickly. This is where we have cos C equals a squared plus b squared minus c squared. And remember, this c is what you're trying to find. It's the angle you're trying to find. So if that's the angle I'm trying to find, that would be my c, and this minus c squared would be the side across from it. And then you have to divide this by 2ab. So that's a cosine law situation where all 3 sides have values on them. I have a Pac-Man situation where I have 2 sides with values plus the angle between them. So here's the Pac-Man situation. This is what I mean. This is, say, 10. This is, say, 20. And although maybe we should swap those around because that doesn't look like it'd be 10 and 20. One's much longer than the other. So let's say that this one's the 10 and this one's the 20, and the angle between them is 120 degrees. This is the Pac-Man situation. And you remember the Pac-Man situation was cos law as well. This is the other form of cos law. This is the form where we start with the side, because if I have this situation, I'm going to be finding this side over here. This would be my side C. So it'd be c squared equals a squared plus b squared minus 2ab cos of the capital C, which is the angle that we have down here. And remember, the a and the b are the 2 sides that make it up. Okay, so that's a situation for cosine law. And case number 4, I have 2 angles and the side between them with no values, with known known values, not no values, known values. So let's say this is 45 degrees in here, and this is 50 degrees in here, and the side between them, let's say, is 15. Okay, now those are the known values. Now, at first glance, this looks like it's nothing, because remember, sine law, I said we had to have a side angle pair with known values. Well, here, I don't have a side angle pair with known values. I've got a side, but I don't have the angle. Or I have this angle, and I don't have this side. Or I have this angle and I don't have this side. So at first glance, it doesn't look right, but we know one other piece of information. We know how to find this angle. This angle we can find very easily using angle sum of a triangle theorem. And angle sum of a triangle theorem just states that there's 180 degrees in this triangle, so I can find that angle. 180 minus 45 minus 50 will be the value of that angle there. And once I have that angle, then I have an angle side pair, like that. And if I have an angle side pair and one other piece of information, which I do, I've got two other angles here, so two pieces of information, this is sine law. So you're going to have to take a look at all your situations and see which one of these cases it falls into, because case 1 and 4 are a sine law situation, and case 2 and case 3 are a cosine law situation. So going on to an example. A cottage under construction is to be 12.6 meters wide. The two sides of the roof here, I'm going to highlight some information here. Here's my number, 12.6 meters wide. The two sides of the roof are to be supported by rafters the same length that meet at a 50-degree angle. So here's what we're talking about, a roof. So we got two sides of the roof that are the same length. So this length and this length are the same length. And they're supporting on top of a cottage that is 12.6 meters wide. So it's right here, 12.6 meters. And it says the two sides of the roof are supported by rafters the same length. Okay, there's our rafters that meet at a 50-degree angle. So where's that 50 go? Is there 50 down here? 50 down here. Where do the rafters meet? Well, let's think about that for a second. This is a rafter, and this is a rafter. So this is the angle where they meet. So that must be the 50. So if that's the angle where they meet, let's put in 50 degrees here. That says how long should each rafter be? Well, the good news is I have an angle side pair. So if I have an angle side pair, this looks like it should be a sine law situation. The problem is, in order to find how long the rafter is, in order to find this length of the rafter, I need to know what that angle is. So we got a little bit of work to do here. The angle side pair tells me I can use sine law, but I need one other piece of information, so I got to be able to do it. Now here's the key here. Remember I talked about angle sum of a triangle theorem before? This is kind of like that last question, because if these two sides are equal, then these two angles down here also have to be equal. And all three of them have to add up to 180 degrees. So if I do 180 degrees minus 50, that's going to give me 130 degrees. Now that's how much I have left for these two angles, but those two angles are exactly the same. So two x's have to equal 130 degrees. So one of those x's has to be 65. In fact, either one of them are 65. So I'm going to take this. We've just figured this one out. We know what these angles are. Those angles both have to be 65 in order for them to be the same, and in order for them to add, for all three of those things to add up to 180. Okay, so now it says, how long are the rafters? Well, this is a sine law situation. Let's quickly go sine law, and we're finding a side. So I'm going to use the value of sine law, and here, let's put something on here. Let's call it R for rafter. So I'm going to put R on top and over the sine of the angle across from R. So the angle across from R is 65. and that's going to equal my side angle pair. And remember, we put r on top, which is the side length, so I need the side on the top, 12.6 over, and then sine 50. Now I'm going to do one little thing here, and I'm going to say, this is for communication marks, I'm going to say using sine law, dot, dot, dot. Okay, now let's solve this. Well, when you got it set up this way, this is easy to get r by itself, because that's what I'm trying to solve for. To get r by itself, I feel like a pirate when I use r. We're going to multiply both sides by the denominator, sine 65, and this time sine 65. Now remember, sine 65 is just a number that your calculator knows what it is, but it's a nasty number. It's got a whole bunch of decimals in it, so I'm not going to change it to a number because sine 65 is neat and tidy to write. But this number is going to cancel with this number, and so all we're left with here is an r. And now we're going to type this in. I'm going to write this out over again so you can see this is 12.6, and I'm multiplying that by the sine of 65, and then I'm going to divide it by the sine 50. You don't have to write this down if you don't want to, but I want you just to sort of look at it and see. Now I'm going to pull out my calculator and type it in so you can see how we do it. So I'm going to put it right underneath there. We put in 12.6 times sine of 55. So 12.6 times, now we want to go 65 and then hit the sine button on this calculator. And I'm going to hit equals. So that's what my top evaluates to. That's what this thing is. And now I have to divide by the sine of 50. So I hit divided by, and now I have to type in 50 sine equals. So that's 14.9. 14.9, and this is a word problem, so we say therefore the rafters are 14.9. And is this meters? Meters. 14.9 meters in length. Okay, let's look at the next one. Oh, we've got a diagram for this one, so this should hopefully help. It says ships A and B at C are 15.6 kilometers apart. A port marked at C, so here's our port. The ships are headed to that port, and the ships can see the port. The angles between the line joining the ships and the line of sight to the port are 58 and 72, so we got those on. How far is each ship from the port? So we need to find this side length and this side length. Well, first of all, I need to know what this is, because I don't have an angle side pair yet. But again, this one's easy to find. Once we get that, then we have an angle side pair very easily. So this, I have to use angle sum of a triangle theorem. I'm going to go 180 minus 58 minus 72. That's 50 degrees. Okay, now that I have my side angle pair, right? Side angle pair, now I can find these other two sides, and I shouldn't have put those little marks on there. Sorry about that, because they're not the same side length. I was just sort of talking and putting marks at the same time. So I'm going to call this side little a, because it's across from angle ship big A, and I'm going to call this one little b. And I'm going to set up sine law here. Let's find little a first. So here's sine law, and I'm going to say using sine law, because I'm not going to write down the sine law. I'm going to say using sine law. And remember, sine law starts with what you're finding. So since we're finding a side, I'm going to start with the side on top. If I was finding an angle, I'd put the angle on top. So a over sine 58 equals, and I'm not going to use b over 72 because I don't want b in there yet. I'll use c, which I know, which is 50, and the 15.6. So the side c is 15.6 over sine 50 degrees. To get a by itself, I'm going to multiply both sides by sine 58. And I multiply this side by the sine of 58. Now these cancel, which gives me a by itself over here. And then I have to multiply this out. Now I'm not going to let you see me do that this time. That's 17.3 kilometers. Now I'm going to do that again with side B. So I'm going to set it up, and then I'm just going to give you the answer here. B over sine 72 equals, and we're going to use that whole ratio again, which is 15.6 over sine 50. And we got to get B by itself. So to get B by itself, we got to get rid of sine 72. So I need a sine 72 on top to cancel out. And if I multiply by sine 72, I got to do it here. Sine 72 degrees. And I'm just going to multiply that out so that I get B equals, that's 19.3 kilometers. And we really should put a concluding statement here, but I don't really have room and I don't really have time. We're already past the 15-minute mark, and I got one more example to do. So let's try to get through this one. A hockey net is 2 meters wide. So I've drawn a hockey net here. I'm going to put on the 2 meters wide. A player shoots from a point where the puck is 3.2 meters from one goalpost. So let's say they're shooting from here. So we draw this on. It's 3.2 meters from that goalpost and 4.4 meters from the other goalpost. Within what angle must he make his shot to hit the net? So this is the angle. He either has to go there to there. So what angle does he have to shoot from? So we need this one. I'm going to put a theta on here. And we have all three sides. So look back at our cases. What do we need if we have all three sides? So looking down, I have this one. I have the triangle with all three sides known. So it's cosine law. So we're going to go back over here and we're going to apply cosine law. It's cosine law where I find an angle. So it's this one. It's cos C equals a squared plus b squared minus c squared over 2ab. Now this one's a little harder than sine law, so really good idea if you write it down. You're going to get better marks if you write it down. Now the angle we're using here is actually theta. So instead of cos C, I'm going to write cos theta. And remember that the side across from the angle, so in this case, the side across from the angle is that 2. That 2 has to be this subtracted value. So that's how we know what order to fill the sides in. And the A and the B, it does not matter which order they go in. I can decide that this is A and this is B or vice versa. It does not matter one bit. So I'm just going to go 3.2 squared plus 4.4 squared. This part matters though. This c squared has to be the side across from the angle. Minus 2 squared over 2 times A, 3.2, times B, 4.4. Now I'm going to let you watch me type this one in. I'm just going to type the top in straight as it is. Watch me. Here, clear that first. We go 3.2 squared plus 4.4 squared minus 2 squared, which is 4, but you can put in 2 squared, equals 25.6 on top. So 25.6 on the top. And on the bottom, we have 2 times 3.2 times 4.4. So on the bottom, we have 28.16. 28.16. Now I'm going to divide those and I'm going to get an answer that has 4 decimal places. So it's going to have more than that, but I'm going to keep 4 decimal places. 25.6 divided by 28.16 equals 0.9090. 0.9090. Now that is the cos of theta. I want theta. So remember how we get theta away? Remember this, ladies and gentlemen? Cos to the negative 1. And I hope you remember how to get that on your calculator. 9090. Here's how we get that on the calculator. We just take, and it's all there still, so I'm just going to leave it there. I go shift and hit the cos. and it says 24.6. Now, if your calculator works forwards, it's a little harder than that, and you may have to talk to me in class, but 24.6. So that equals 24.6, and that's in degrees. So he has to shoot through an angle 24.6 degrees to make sure that he gets it on net. That's a pretty small angle. And that hit the 20-minute mark, so I'm going to stop that right now.